Hello. Our next lesson in our Exponents and Scientific Notation unit is dividing powers of 10. So today we're going to think about what patterns emerge when we divide powers of 10. In your warm-up, you're going to be looking at the expression and asking yourselves, what is the value of this expression? And in the blue box, you're going to explain, how did you figure that out? So pause the video, look at that expression, and try to come up with your best estimate or calculation to show the value of that expression. Now that you've had some time to think independently about the value of this expression, I want us to think back to something that we discussed a couple lessons ago about multiplying numbers in exponential form. To review, when we worked on multiplying powers of 10, we changed those powers of 10 from exponential form into expanded form. So you can see that these examples show that same pattern that we discovered with powers of 10. The only difference is that we're looking at a base of 3 here. So we can see in the top row, we have 3 to the 5th power times 3 to the 2nd power. And when we expand that out, 3 to the 5th becomes 3 times 3 times 3 times 3 times 3, and 3 to the 2nd power becomes 3 times 3. So that demonstrates why we can simplify that same expression to be 3 to the 7th power. And as mathematicians, we always want to be trying to write things in the simplest way possible. So we came up with a rule together, which was that when we're multiplying numbers in exponential form, we can add the exponents. So going back to our warm-up, look for where you see numbers in exponential form with the same base, and consider how could you simplify the numerator, or the top part of this expression, and the denominator, or the bottom part of this expression. Because what we have here is 2 to the 5th times 3 to the 4th times 3 to the 2nd divided by 2 times 3 to the 6th times 2 to the 4th. So if you were stuck at all in this problem, think back to that idea of simplifying. That's always a really helpful place to start so that you can make the problem simpler and simpler until it's simple enough that it makes sense to you. So take a moment, and if you did not already, combine those numbers in exponential form with the same base and see if that helps you come up with an answer. Moving into our Explore section, we're going to interpret and explain the table in the middle of your screen. So it says the image below displays the first 2 rows of a table. And the headings of our table say expression on the left, expanded in the middle, and single powers of 10 on the right. So our expression that we have in the first row of our table is 10 to the 4th power divided by 10 to the 2nd power. And I just want you to pay attention to the different notations for division. So in our warm-up and in the expanded part of this table, we're showing division like a fraction. So fractions are always division, where we are taking the numerator and dividing it by the denominator. So when we say 10 to the 4th power divided by 10 to the 2nd, we can write it as a fraction with 10 to the 4th as the numerator and 10 to the 2nd as the denominator, like we've expanded in the middle. Or we can write it with the division symbol you might be a little more used to on the left where it says expression. So your goal right now is to describe what you think is happening in the expanded column of the table. And I encourage you to think back to what we did when we were multiplying powers of 10 and see if you can relate it to this problem. Now that you've had time to come up with your answer for what you think is happening in the expanded column of the table, I want you to focus your attention on a specific piece of information here. So I want you to look at how this 10 times 10 divided by 10 times 10 becomes 1. That's in green. And then how what's left over becomes our single power of 10. So pay attention when you go into the next slide and when you think about dividing numbers in exponential notation. Think about what can become a 1, which we remember when we multiply 1 times anything, we get that value back, right? So 1 times 5 is 5, 1 times 100 is 100, 1 times negative 1/3 is negative 1/3. When we're dividing numbers in exponential form, think about what becomes a 1 and what is left over. So now we're in the second part of our Explorer section where we're going to continue with the table that we examined on the previous slide, slide B. So your goal here is to complete the table, then answer the questions that follow on the next slide. You may skip a single box in the table, but if you do, be prepared to explain why you skipped it. So you can skip one of those 5 blue boxes in your answer, as long as you have a reason why you chose that box to skip. So look at the table and what we have filled out so far, and see if you can come up with at least 4 responses for the missing parts of the table. And you can pause and take some time to think about that. Now we are in slide D of our Explore section, and you're going to be using the information from slide C to answer these questions. So you may want to skip back and forth between slide C and slide D as you're answering. So our first question is, if you chose to skip one entry in the table, which entry did you skip and why? So looking back at slide C, and looking at the different exponents we're dealing with in the expression column, I think there's one expression that might have been pretty annoying to fill out in the expanded column. So the one that you might have picked helps demonstrate the reason why it's important for us to come up with a pattern that we see that helps us come up with a rule, so that we don't always have to expand in order to come up with our answer. So you're explaining some of that thinking in number 1. So now on our second question on slide D, you're going to analyze the expression column and the single power of 10 column and explain what pattern do you see. So this is the step where we take our pattern and we come up with a rule. So remember, we came up with a rule for multiplying numbers in exponential form. When we multiply numbers in exponential form, we add the exponents. You are going to look back at dividing numbers in exponential form and see if you can come up with a rule that would help you so that you don't always have to expand to come up with your answer. Finally, you're going to generalize that pattern by rewriting 10 to the n divided by 10 to the m power using a single power. So what rule did you find? And in the last question, you're going to express that rule algebraically with those variables of n and m. So now that you've had some time to work on slide D and come up with your answer to those 3 questions, you're going to attack this problem on slide E, and I'm going to read it aloud for you while you read along first. So it is predicted that by 2050, there will be 10 to the 10th power people living on Earth. At that time, it is predicted there will be approximately 10 to the 12th power trees. How many trees will there be for each person? So pause the video and apply those patterns that you saw in the table on the previous slides to help you come up with an answer to this question. And I encourage you to use our 3-read strategy. So ask yourself, what is this problem about? What is the question asking? And what information is important? And then you'll write your answer in the blue box. Pause so you have time to do that. We've made it to the final part of our lesson for today, which is our summarize section. This is our most important part of the lesson because it's where we bring everything together and we make sure that we're going to remember it in the future. So to prepare for the summary, record your response to the focus question. So that's our question from the very beginning of the lesson. What patterns emerge when we divide powers of 10. So you're going to answer on that left-hand side, and you can use the space to the right to record any notes as you go over what you've learned today.